I, Dr. Atul Bhatnagar from Department of Chemistry, SRLS Government PG College, Kaladera. Welcome you all in this e-lecture. This e-lecture is being prepared for the students of MSc final year. Today, we shall be discussing pericyclic reaction. In this first lecture, we shall discuss about what pericyclic reactions are. That means we shall be I shall be introducing pericyclic reactions to you all. Further, we shall discuss type of pericyclic reaction, how these pericyclic reactions has been classified, in what manner they have been classified, on what basis these reactions has been classified. So first of all, we shall start with the introduction of pericyclic reaction. Pericyclic reactions, their word pericyclic means around the circle. So in this reaction, in all such type of pericyclic reactions, we shall see there is a fast or intensive movement of pi electrons around the cycle. Whether a open chain structure is converted into a closed cycle, or a closed structure is converted into a open structure, there shall be a movement of pi electrons within the molecule, or between the two molecules, or even the group can be migrated. But ultimately we shall see there is a movement of pi electron, formation of new sigma bond, formation of new pi bond, or loss of sigma bond, or loss of pi bond. In some cases there may be formation of sigma bond and no loss of pi bond. So all such type of reactions are known as pericyclic reactions. Now we come to the point. How this movement of electron takes place. Pi electron gain energy, and this gained energy is known as energy of activation. What are the source of this energy? Source may be a heat. We may supply heat to the reaction, and by absorbing energy from the heat, pi electrons are excited and they show such type of movement. In that case, the reaction is known as thermal induced reaction, because energy of activation is provided to the molecule thermally. Second source of energy may be ultraviolet rays. If we are using any ultraviolet light source, then we are providing photons to the reaction. Pi electron, they absorbs photons from the UV light and excited for the movement, or they gain energy of activation. Since the reaction is started or energy is being provided by UV light, that is photon, so it is known as photo-induced reactions. These are the basics what pericyclic reactions are, how these reactions takes place. Now we shall discuss the type of pericyclic reaction or the classification of pericyclic reaction. Pericyclic reactions, they basically have been classified under four heads. Four type of pericyclic reactions we can say. So first type of pericyclic reaction is electrocyclic reaction. What electrocyclic reactions are? Electrocyclic reactions takes place due to which a open chain structure is converted into a cyclic structure, or cyclic structure may be converted into open chain structure. If a ring is closed That means open structure is being converted into closed circle cyclic compound. In that case, there shall be a gain of one sigma bond. At the same time, molecule shall lose one pi bond. We are talking of conversion of open structure into cyclic structure. How this happen? How this happen? We shall see in the example. This is a compound CH2 CH 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 CH2. Pi bonds are present there. Alternate pi bonds are present there. So a shift of pi electrons that will take place on supply of energy. How this will take place? This pi bond between terminal and next to terminal carbon atom will be shifted between these two carbon atoms. As soon as this bond is shifted here, this bond will shift from these to this place. This is now we can say C1, C2, C3, C4, C5, C6. So the bond between C1 and C2 carbon atom is shifted between C2 and C3 carbon atom. Because of this shifting, the bond present between C3 and C4 carbon atom will be shifted between C4 and C5 carbon atom. So this is the shifting of pi electrons, pi bond, not sigma bond. Now we come to the point. This double bond or pi bond present between C5 and C6 carbon atom will be shifted between C1 and C6 carbon atom. Here in the product we are indicating by this red line, this bond. This is a sigma bond. So we can see in the product there are two pi bonds, whereas in the reactant there were three pi bonds. So one pi bond has lost. At the same time, a new sigma bond is created between C1 and C6 carbon atom. So what we can say in a open chain structure, when open chain structured compound undergo electrocyclic reaction, there will be a loss of one pi bond, and at the same time there shall be a gain of one sigma bond. This is a type of electrocyclic reaction. Now we can take reverse example of this. Open chain structure compound is obtained by breaking of sigma bond or conversion of sigma bond into pi bond. So here the case will be just opposite. There will be a loss of sigma bond and gain of pi bond. Vice versa of first example. This is the example. This sigma bond, this undergo cleavage. How? This sigma bond is shifted between these two carbon atoms as pi bond, and this bond will be shifted. Similarly, this bond will be shifted here. We will be getting a compound with open structure in which three pi bonds are available and sigma bond is lost. So this type of reaction, both type of reaction, they are known as electrocyclic reaction. This is one type of pericyclic reaction. Now we come to second type of pericyclic reaction. Second type of pericyclic reaction is known as cycloaddition reaction. Cycloaddition reaction means two reactants, they are reacting with each other and both the reactant have pi electron system. At the time of reaction, both reactant will lose one pi bond each. What we can say? We are having two reactants, both are having pi electron system, pi bonds are there, they react with each other, and as a result cyclic compound is obtained. During the course of reaction, each molecule or each reactant will lose one pi bond, and these two pi bonds are converted into two sigma bonds. How this reaction takes place? The reaction can be seen as here. This is the molecule of ethylene CH2 CH2. Again second molecule of ethylene CH2 CH2. Reaction is taking place in the presence of H nu, that is in presence of photon, or energy of activation is received from photon. So we say the reaction is photoinduced. This pi bond will be shifted between these two atoms, these two molecules, and both the molecules will be joined together at terminal carbon atom. This CH2 terminal carbon atom of one molecule will be joined or will be linked or will be cycled with an CH2, that is terminal carbon atom of second molecule. Similarly, this pi bond that shifts between these two carbon atoms. So we are losing this pi bond, we are losing this pi bond, and there is a formation of new sigma bond. This is the sigma bond. We can say this is sigma bond, and again this is sigma bond. Two new sigma bonds have been formed and two pi bonds are lost. This is the reaction. Such type of reaction is called cycloaddition reaction. Another example we can take 1,3-butadiene CH2 CH CH CH2. This molecule 1,3-butadiene, that is reacting with ethylene. This is thermally induced reaction. We are supplying heat and we are supplying energy of activation through heat, and this reaction is known as thermally induced. This pi bond shall be shifted between these two carbon atom, terminal carbon atom. Similarly, this CH2 will lose one pi bond and the bond will be shifted between these two carbon atoms. So we can see there is a formation of one sigma bond at the cost of one pi bond. This is another sigma bond formed at the cost of another pi bond. This double bond has been created between these two carbon atoms as a cyclic shift. So this is another example of cycloaddition reactions. Now we come to third type of cycloaddition reaction, third type of pericyclic reaction. This is known as sigmatropic rearrangement. Rearrangement of molecule is there. In such type of reactions, there is no loss of pi bond. Simply one sigma bond that migrates from one end of the atom to another end of the atom within the molecule. Reaction is taking place within the molecule, only rearrangement of molecule groups or atoms attached to various carbon atoms are taking place. In this example, we can say one sigma bond or a group attached with the sigma bond with one carbon atom is shifted to another end, another terminal carbon atom. There is no loss of pi bond. Although there is a shifting of pi bond, but there is no loss of pi bond. Such type of reactions, they are known as sigmatropic reaction. Now we take an example of sigmatropic rearrangement. This is a molecule. Terminal carbon atom CH2. Two hydrogen atoms are there. CH2, CH, CH, CH. Now this terminal carbon atom is having 3 valency. And 3 hydrogen has been replaced by deuterium. This is deuterium D. Again hydrogen has been replaced by deuterium. Again hydrogen has been replaced by deuterium. This replacement has been done before the start of reaction, so that we can come to know really a group has been migrated from one carbon atom to another. When the reaction is carried out, this sigma bond that shifts from this carbon atom to this carbon atom. This is terminal carbon atom. This is terminal carbon atom. So a group has been shifted, or sigma bond has been shifted from one terminal carbon atom to another terminal carbon atom. We shall be getting this product in which terminal carbon atom is having one deuterium along with 2 hydrogen, and one deuterium from first terminal carbon atom is lost or is shifted. This type of reaction is called sigmatropic reaction. Due to this shifting, this pi bond will shift from this carbon atom to this place, and this pi electron system will be shifted between these 2 carbon atoms. So shifting of pi bond takes place, but migration of sigma bond takes place. There is no loss of sigma or pi bond. Now we come to last type of reaction, that is known as group transfer reaction. What is group transfer reaction? If we see a compound, a molecule, and in that molecule one complete group that migrates from one molecule to the another molecule, and due to this shifting a new sigma bond is formed between the 2 molecules. Now we are not talking of the same molecule, we are talking of the molecules, that is between at least 2 molecules. This is the reaction in which at least two molecules are taking place. Group from one molecule is being shifted to another molecule. How this takes place? This is the reaction. In this reaction we can see this is CH2, CH, CH2, one H and another H. So this is a group. This group shifts from this molecule to this molecule at this end, and there will be a breakage of this bond. Now hydrogen will be linked with this carbon atom, not with this. As a result, this bond will be shifted between these 2 carbon atoms, these 2, 1 and 2. As soon as this group is transferred, this pi bond will be shifted as sigma bond here between the 2 molecules. So we can represent this new sigma bond as red ink. With the red ink we are indicating formation of new sigma bond, and this hydrogen has been again inked with red. Red inked hydrogen is now attached with the carbon of another molecule, and 2 molecules they have been joined by the formation of new sigma bond. This is the group transfer reaction. We shall be discussing each of the reaction in a detail starting with the electrocyclic reactions in next coming e-lectures. At the end, I shall thank you to all of you for listening this lesson or this e-lecture, and shall request you to subscribe this channel and like the videos. After liking these videos will be preserved in your library, YouTube library. At the time of need, you can go through them. Otherwise, you will have to look around. You can subscribe the channel, so the channel link will be with you. You can go to the channel and see or can download or can go through the videos available there. Once again, thank you.